is motion? Has anybody any idea what motion is? And motion has been talked about since days of old, at least since the days of the Greek. And I'm sure that the Greeks did not come up with all this on their own. I think they inherited a lot of the stuff from perhaps the Egyptians, Persians, maybe the Sumerians. I think all that was passed on from one generation to the next, from one empire to the next. We got ours primarily from the Greeks because they formalized it and because their records survived. Okay, so here we have perhaps the most thorough researcher in this matter. He's called a philosopher. I don't think they were philosophers at all. Philosophy is something else. But his name is Aristotle. Okay? And so this is what, in a nutshell, I mean, you got to read the book and go into more detail to get to the bottom of it. But this gives you a snapshot of how Aristotle was thinking, or not. This is out of his book Physics, approximately 350 BC. Okay? Motion, fulfillment of what exists potentially. He says you have potentiality, something that can become something different in the future. Okay? And he says it has this potential, and when it's fulfilled, when the potential is fulfilled, he calls that motion. That was his reasoning. Okay? That's how he defined it. Okay? He can continue. He said, well, motion is continuous. Okay, what do you mean by continuous? Like, no interruptions? What? No, exactly the opposite. The word continuous, according to Aristotle or his translator, which you also have to look at, right? Continuous is what is infinitely divisible. Meaning, if you can chop it into pieces, then it's continuous. And we have a different definition of continuous. Continuous is that which is made of a single piece. That's continuous. Not if it's chopped into segments, that is not continuous. Okay, segments are not continuous. I mean, each segment could be if it's made of a single piece, but a series of segments is not continuous. But that's the notion they had. And so he had this notion that motion was chopped into pieces. What pieces? Voids, which they called places. They called it voids as well, but today the word that would be used for that is position. Okay, so they had all these positions or locations you could even use, right? They called it void, or it was translated as void or places. So what is motion made of? Motion is made of chunks of places, of voids, of locations, of positions. And so he calls that continuous. Okay, because he says continuous is what you can chop up into little pieces. Okay, why? He was thinking of the number line, because they're going to put numbers, or think of it in terms of numbers, that they're going to put a number per location, maybe an ordered pair, right? Okay, so this is where all this went. It went into mathematics. Okay, they started putting numbers to locations, and they started talking about motion in terms of location, meaning displacement, distance traveled, to which one they're going to put a number, so many meters. What is a meter made out of? Well, centimeters, millimeters, micrometers, etc. Okay, and then he says time indeed and movement are infinite. Okay, no, the word is not infinite. Again, poor language, maybe it's poor translation, maybe they had the right idea, maybe the translator did it wrong. No, infinite is an adjective. You do not use it to qualify motion. Okay, so you cannot say that motion is infinite, time is infinite. It's irrational. You're using an adjective to qualify a concept. That's irrational in science. Okay, you can use adjectives like black or whatever to qualify an object, a thing. You can say that object, that table is black or brown or whatever. You can say that. That you can use an adjective for, but you can't say that the table is infinite. First of all, you cannot say a table is infinite because all objects are finite. It's that which has shape. And then if it's an infinite table, it means what? That there's nothing outside of it, meaning you cannot even imagine that it's an object. So infinite object is an oxymoron. It destroys itself. Okay, so in book 3, he says motion is change of place. I'm sorry, in book 4, he says motion is change of place, meaning you're going to go from one location to another. That's pretty much the definition that we have today, 2 or more locations. That's correct. Okay, but it's like, they don't listen to what they're saying. They don't even pay attention to what they're saying. They say a change of place, but then we have a problem. First of all, because motion is change, and change is motion. You can't have change without motion. Therefore, you cannot use the word change ever to define motion, which is how it's defined today. If you look up the word motion anywhere, it says change of location, change of place, or change something. You can't use the word change because change is motion. You're saying motion is motion. That's all you said. You use the synonym to define with quotation, circular definition. That's what a synonym is. You use a synonym to define motion. You can't do that. Okay, it says a body moves from place to place. Again, he has this notion that motion is a body, a thing, a figure, as Euclid would call it, a figure moving from one location, from one void to another. Okay, this was the notion they had. Okay, motion therefore is infinitely divisible. Why? Because it's made out of pieces, right? Into discrete places, locations. Okay, so this is the notion with which we started. This is the one we inherited. Okay, did we do any better? No, because as you talked about the other day, all the way up to good old Newton, good old Newt. What did Newt define? Well, he said, I don't define motion because everybody knows what it is. So nobody defined motion to this day. And this is very easily. People sometimes say, I have a definition for the word object. I have a definition for the word motion. And they go to the Wikipedia or they go to some kind of scientific dictionary or encyclopedia. And that's the wrong place to look for it. Okay? Why don't you do it the scientific way, right? And look for it in a book of physics. Get any textbook of physics on the planet, from the past or from the present, even from the future. And I want you to look for the word motion and for the word object. See if you find them defined anywhere in any textbook on earth of physics. Okay? Then you can show to me that you have a scientific definition. But to say you go to the dictionary, well, you go to the dictionary, it's from ordinary speech. The people who write dictionaries are English majors or librarians. They're not scientists. And what the physicists, so-called mathematical physicists, mathematicians do, they go to the ordinary dictionary and they say, okay, there, I found what an object is. I found what motion is. And then they put that into encyclopedias like the Wikipedia or whatever, scientific encyclopedia. And then you find it there and say, oh, there's the scientific definition. Now, that so-called scientific definition came from the ordinary dictionary, which came from librarians who have no stake in physics. No, if you're honest with yourself, show me a book of physics, so-called physics, the ones that they teach in high school and college. Any textbook, I'll buy you a beer. If you can come up with one book, any textbook that begins by defining the word object, without which you can't do physics. You can't do physics without an object. Just look for a book that has the word object defined and then the word motion. And no, you won't find it. You won't find the word motion anywhere, not defined. Like motion, colon, and this is the definition. You won't find it. Okay? So everybody's essentially relying on good old Aristotle, who said that it's a change in position, a change of place, and change is a synonym of motion. So we have a circular definition. We have synonyms. That's all we have. Okay, so what is this? Motion, time, what is all this stuff? And when people want to illustrate time, what they do is usually draw a line with an arrow, because they say it increases in that direction. 1 second, 2 seconds, 3 seconds, 10 seconds, 1 hour. Time increases in a given direction. So they put in a line and they put an arrowhead at the end of that line. They're going to be using Cartesian coordinates, right? Most of you are familiar with those notions. And this is what they draw. It says, one person says, this is where time also comes in. One fellow says, if there is motion, we have time involved. Well, no, not true. When there is time, you have motion involved, but not in reverse. You can have motion without time. Okay? And again, let's show that. Okay, here it is. This is how they illustrate time usually. They put an arrow and they say, that's time. Okay, and time increases or whatever towards the right in this case. Okay, but this is how it's illustrated. Okay, the problem is that what you're staring at is not time. Right now you have no comparison with anything, so how do you know how many seconds went by or whatever? Okay, what you have there, if anything, you have motion. That's what you have. That's what you have there. You have motion. Okay, so if you draw a single arrow, you're not illustrating time. You're illustrating motion. Okay, so let's replace that time with motion. Okay, that's what we have. Okay, so we have motion, and there seems to be a little bit of problem there, but first let's look at time. Here's time, okay? If motion is a single arrow, what is time? Well, time is two arrows. It's a comparison of two motions. Okay, you need two motions to compare them one against the other in order to come up with time. Okay, but again, we still have a problem. Why? Because that does not really illustrate something important, and that's what Aristotle said, and that's that the arrows have to be segmented. You have to chop them into pieces because you're going to talk about motion being made of locations. And here it is. You have to have locations. You have to have motion, two or more locations of an object. That's where you start. And then you have time, which is a comparison of two motions. And for that, you're going to need memory. You need someone to memorize all that stuff. Okay. But what do we have? If you have locations, you're saying, okay, if you have like the universal movie, what I call the universal movie, for every frame in that movie, all you have in each frame of that movie is location. And this is how I illustrate it here. Okay, here you have Mother Nature, and she's in a film. Okay, and you have Mother Nature. All she has is one location at a time in each frame. Okay, you heard of movies? What are movies? Well, movies are motion pictures. You have pictures in motion. Why are they in motion? Because you have many frames, and it gives you the impression that there is some action going on the screen. But in order to have a film, you need to have many frames, and each frame only has location, objects just at a given distance from each other. When you take the set of locations, the set of distances from one object to the to all others, you have location, and that's all you have in one frame of those films. Okay. Okay. So what you have is this movie of Mother Nature there, and that whole film strip, it just occupies a little piece of strip, a little strip there of that movie. And what you have on one side and the other, those black marks, those are just locations. All you have within each one, which is what you can call a cross section of time, a cross section of motion, all you have is location, just one location, static concepts. Okay, we're going to construct motion with many locations. Okay, and it looks more or less like this. Okay, here you see it. Okay. And what is time in this context? Well, what you have for time is that you're comparing two motions. What are you comparing? Well, just an example here. Okay, you have the tick marks on your clock, and that's the second hand. Okay, the one that counts seconds, and it goes from one tick mark to the next. By the time it went from one tick mark to the next, maybe it's just a 1 millimeter trip. That's the distance traveled. The Earth, meanwhile, traveled 30 kilometers. Okay, now you can chop that film strip of 1 millimeter in one case and 30 kilometers in the other. Okay, you can chop it as much as you want. For the universal movie, all we had was one location at a time for every object in the entire universe. Every object in the entire universe just had one location with respect to each other for one frame of the universal movie, and you can make that frame as small as you want. It doesn't matter. You're going to have one frame only, and all you have is a static image with every object just far away from each other. That's all you have. And so that second hand there, the one that moved 1 millimeter, right? It has to match the distance of the Earth traveled. So if I were to cut that film, the universal movie film, right, into frames, one frame only, all I would see in that frame is the second hand at a certain location and the Earth at a second location with respect to the sun, obviously, right? And if I go to another frame, I'm going to find a different location for the second hand and a different location for the Earth. But they have to match because 1 second equals 30 kilometers. What you're doing is comparing the motion of the Earth against the motion of the second hand on your watch. That's what it is. And that's what time is. So you need two motions. If you only have what you see on the top, just one dotted line, okay, then you do not have time. All you have is motion. Okay, so we distinguish motion from time. Motion just requires one line with a bunch of locations. Time, you still don't have time. You want time, you need two motions. And you need memory. Okay, you need an observer for time. That's why time has nothing to do with science. We don't use time in science. It's only the religious people of mathematics, the mathematicians. They're the ones who put in time because they want to describe things. They want to put a number in an equation. We have no use for any of that. Okay? We have no use for time whatsoever in science. In science, we have to explain why, what causes this pencil to fall to the floor. I don't need to know how much time it took. Not important, not relevant. All I need to show is the mechanism of what brought that pencil down to the earth. Okay, so let's look at here, subject matter which we started today, and that relates to this subject. Okay, here's called the present. Now, people say, well, where does the present belong? Are we talking about motion? Are we talking about time? What are we talking about? Is the present a static concept? Are we talking about location? Is present related to location, to motion, or to time? What is the present related to? That's the question. And so let's go through step by step. Present is a cross section of time. It's present is the cross section of motion. What was a cross section of motion? Location. So when you talk about the now, you talk about the meeting of the past with the present. Okay, so you have the movie of the past, everything that happened in the past, the movie of the future, right? Past and the future. And in between, squeezed within there, in a single frame, you have the present, the now. What is the present, the now? Location. That's where Mother Nature exists. She exists in the present location only. There is no motion. Okay, she's in a single frame of the universal movie, and then she moves on to the next frame, next frame, next frame, and builds this movie called the universal movie. Everything moving in the universe. But for one frame, all we have is location. That is known as the now. That's known as the present. So the present really has nothing to do with time or with motion. It has to do with location. Okay. Present, not equal to two locations. The present is a single frame in the film, only one location. Okay, and you can't use the word instant to refer to the present, because people many times use, oh, it was instantaneous, or it's instant coffee. How long did it take you to make that instant coffee? Instantaneous is a notion that confuses people, because people think instantaneous and they're saying, oh, okay, it happened so rapidly that I could not even measure it. That's the notion they have. But see, instantaneous involves an interval if it's time, and instantaneous only belongs to time. They're talking about an interval of time, because time can only be an interval. There is no such thing as really a cross-section of time, a cross-section of motion, because now you're talking about a static concept. You're talking about the now, the present, what? Location. Okay, so we have to distinguish that in physics, location from motion, not to mention time, which we have no use for. Okay, so the present is not equal to distance traveled. It's not equal to two locations. It's equal to distance, separation. Okay, and many separations, many distances, that's what we call location. All those are static concepts. All those should appear in a single frame of the universal movie. Okay, so the present is equal to location. Present, meeting between the past and the future, but present is not equal to an interval. It's not instantaneous, the present. Okay? So we have to understand the concepts here. We have to understand what location, motion, and time are from a conceptual point of view. Okay, here we have rerun, quick rerun. I didn't put area in there. The Eleatics talked about the other day, and they said there is no motion, no such thing as motion. And they said because for that you would have to have the void exist in order for something to occupy the void, okay, which is what Aristotle's going to say. And so they went through this reasoning saying there is no motion. And the atomists, like Democritus and Leucippus, they said, you guys are crazy. Here's motion. I'm moving my hand. Okay, so don't tell me there's no motion. Okay, so it was like something, again, what is it? Gaslighting? The guy saying, it's a fact, there is no motion. What do you mean? Here's motion, this is a fact. They all believed in different facts. Okay, and they're staring at motion. They say, I don't believe you. I don't believe there's motion. Okay. No, he doesn't define motion because he says everybody knows what it is. And we get all the way to Mr. Heisenberg, Werner Heisenberg, and he says, when the ball moves, it doesn't stand still. When it stands still, it doesn't move. Known as the uncertainty principle. Such poppycock. This is what these people got a degree for, to say such stupid things as that. That the more you know about position, the less you know about motion. The more you know about motion, the less you know about position. Yeah, no kidding. Did you have to go to the university to figure that out? Did you need an equation to figure that out? Okay, so here are the conclusions, okay, for motion. Okay, run through these different aspects of it. Motion is two locations. That's what motion is. What is time? Time is a comparison of two motions. You require memory, you need an observer, and therefore we have no use for time in science, let alone in physics. Okay, time belongs exclusively to the religion of mathematics because they need to put a value in an equation. Okay, Mother Nature has no idea of time. Mother Nature has no idea of motion. Mother Nature exists in the present. She only exists now for every frame of the universal movie. Okay, exist. You need to have location. It's a static concept. Okay, you need an object with location. What is present? Location. So what you see in the universal movie in a single frame is what exists, and that's all that Mother Nature understands. Okay, the present is a cross section of time, of motion. Also, you can look at it that way. Okay, we're talking about a single location. Okay, and present is a single frame of the universal movie. Okay, now Aristotle said, well, motion is continuous because, it's infinite and it's continuous, and continuous means you can chop it up into little locations or voids or places, as he called them, or at least translated as such. He said time is continuous. Again, you can chop it into little seconds, and that means that you have these units, and they had this notion of location. That's what they chopped time and motion into, discrete locations, okay? But if motion is continuous, made of, according to Aristotle, right, made of discrete locations, we have a problem. Because an object is what is discrete. You can say an object has surface, it's that which has shape, and therefore is discrete. Location is a concept. Locations do not have shape. They don't have size. They don't have anything. It's a concept. So it's irrational to say that location is discrete. Okay, you don't make concepts discrete. Only objects can be discrete, physically discrete in science, in physics. Okay, location is a concept, so you cannot say that it's discrete. So location is a set of distances to an object, and you can take it from the surface or from the center of the object. It's up to you. That's arbitrary. But the point here is that motion is made of locations, but the location is not discrete. Okay, so it's continuous. Why? Because location itself is not discrete. Okay, so this is where Aristotle failed. No one figured that out in 10,000 years. Okay, yeah, you have to differentiate between objects and concepts. Object is that which is discrete. Concepts cannot be discrete at all, so you cannot talk about motion being made of pieces. Okay, so this is where the problem is. Okay, no origin to motion. This is another issue. Nobody created motion. The single thread has always been there. No origin to the single thread. Therefore, no origin to atoms and no creation of matter, like in mathematical physics, specifically in general relativity, which they say, you know, there was this Big Bang that created matter. How do you create something from nothing? I don't know. But that's what they do in not only in general relativity, but they do it also in quantum mechanics. You know, you have particles coming in from the void, meaning the void is made out of particles. And it turns out that the void itself, space, was created at the Big Bang. Meaning before that there was no space. So what was there? Nothing? What is space? I thought space was nothing. And so again, you get this runaround from the establishment because they never solved that. In fact, they say it's beyond science. That's unscientific. That's philosophy or something, you know, out there. So they have this theory that, you know, the universe started at the Big Bang, meaning matter was created at the Big Bang, space was created at the Big Bang, time itself was created at the Big Bang. And so you say, well, what was there before that? And they say, don't ask that question. It's an unscientific question because we cannot test the hypothesis.